just mind-blowing how quickly we went from figuring out basic electricity to actually thinking about artificial minds.
It really is. Seems like no time at all, relatively speaking.
It really makes you think about how fast knowledge can just compound.
Anyway.
Welcome, everyone, to the Deep Dive. This is where we unpack the core ideas from sources you send us.
And today, we're diving into intelligence, the natural kind, the artificial kind, all through the lens of Ray Kurzweil's book, How to Create a Mind.
Right.
And this book, it came out back in 2012, but it's still pretty relevant. It covers a lot from how the brain works to, the big philosophical questions about consciousness.
So our mission today is really to pull out those key insights about intelligence itself, right? See what stands out.
Exactly. Get to the heart of his arguments.
Okay, so where do we start? Kurzweil kicks things off with this idea that progress isn't steady, it actually speeds up.
Right.
The law of accelerating returns, or LOAR, I guess we can call it.
Yeah.
What's the core idea there?
Yeah. So LAR basically says that evolution, and this applies to both biology and technology, inherently accelerates. It's exponential, meaning each step makes the next step possible and potentially faster or more powerful. So the rate of change itself increases over time. Think of it like a snowball rolling downhill, getting bigger and faster.
It's not just a straight line upwards.
Not at all. It's a curve that gets steeper and steeper.
And he doesn't just, state this.
Yeah.
He provides examples, right? Historical trends.
Oh, definitely. Information technology is his go-to example. He shows this really consistent exponential pattern in computing more power, lower cost, year after year.
For decades now.
Exactly. Look at the difference between those old room-sized computers and the smartphone in your pocket. That wasn't gradual progress. It was explosive growth, driven by this acceleration.
He wrote about this in his earlier books too, right? The age of spiritual machines, the singularity is near. This accelerating change is a central theme for him.
It absolutely is. It underpins pretty much his entire outlook on the future of technology and humanity.
And he also ties LOA into how knowledge itself is structured, particularly now with the internet.
That's a really interesting connection. He argues that the world and our knowledge of it tends to be hierarchical. Think biology, cells, tissues, organs, systems.
Okay.
Or even just how we categorize things.
Yeah.
The internet, with its links and layers, kind of reflects this. This structure, he thinks, makes it easier to build on what we know and accelerate discovery even faster. It's like having a framework already in place.
Makes sense. So if technology is accelerating like this, it leads naturally to thinking about, the ultimate intelligence system we know, the human brain. Trying to understand that.
Which is, a massive undertaking.
Feels incredibly daunting.
For sure. There's this huge global effort, neuroscience projects trying to map it, understand it, and the motivation is clear. The brain is our best example of intelligence. If you want to understand or build intelligence, you look at the brain.
He had a kind of provocative take on this, related to searching for aliens, didn't he? And the singularity is near. Something about why we haven't found them.
Yeah. That's a fascinating bit. He suggests that maybe the reason we don't see signals from other advanced civilizations is because technology accelerates so fast that they quickly move beyond recognizable technologies like radio waves. They might transition to something else entirely, almost incomprehensibly advanced in a relatively short evolutionary timescale.
Wow. So from that viewpoint, understanding our own brain
becomes maybe the most important project there is. If intelligence progresses that rapidly, figuring out our own blueprint is critical.
But the sheer scale of it, billions of cells, trillions of connections, how do you even begin to reverse engineer that? It seems almost impossible.
The numbers are definitely intimidating. But Kurzweil's perspective is a bit more, maybe, optimistic. He argues that while the brain is vast, the principles it uses, especially in the neocortex, might be based on understandable, even recreatable patterns.
Like finding the core algorithm running complex software.
Sort of, yeah. The idea is that the complexity we see might emerge from relatively simpler, repeated computational processes. We don't need to replicate every single neuron perfectly, maybe, but understand the fundamental pattern processing methods.
Which brings us neatly to his core theory, the pattern recognition theory of mind, or PRTM.
Exactly. This is central to the book. PRTM focuses on the neocortex, that outer layer of the brain, much more developed in mammals, especially humans.
And that's the part that does the thinking.
Pretty much, yeah. It handles sensory input, recognizing faces, objects, sounds, but also planning movements, reasoning, language. All of it, Kurzweil argues, boils down to recognizing, learning, and using patterns in a hierarchical way.
Hierarchical. Like layers.
Precisely. It's not just one flat system. He uses the analogy of a forest immense complexity, but it arises from many similar elements, like trees, following certain growth patterns. The neocortex, he suggests, has a repeating fundamental structure or circuit that processes patterns.
So how does it work? How does it recognize a pattern? Let's say seeing a chair.
Well, according to PRTM, lower levels might recognize simple features, lines, curves, angles. The next level up combines those into slightly more complex patterns, like leg or seat. Higher levels still combine those patterns until you get the concept chair. It builds up complexity.
And memory fits in here too.
Yeah.
Because our memories aren't like perfect recordings.
Right. In this model, memories aren't stored like files, they are sequences of patterns. Recalling something means activating a pattern, which then triggers associated patterns in a sequence.
Ah, like links on a web page. One thing leads to another.
That's a good analogy, yeah. Thoughts trigger other thoughts, which are themselves patterns. And he distinguishes between, like, non-directed thinking, just letting your mind wander, free association, and directed thinking, which is more logical and goal-oriented, but both rely on activating these learned sequences of patterns.
It's really interesting how he connects this theory directly back to his own work in the 80s and 90s on speech recognition.
It really is. He was developing these hierarchical hidden Markov models, or HMMs, and the structure they used. It's surprisingly similar to how he describes the neocortex working.
How so?
Well, these systems analyze speech in layers. First, basic sound frequencies, then phonemes, the basic units of sound, then combining those into words, then phrases, and trying to get the meaning. It's that same hierarchical pattern recognition idea.
And systems like Siri or Google Voice Search today, they build on those principles.
Very much so. The underlying approach of analyzing information in hierarchical statistical patterns owes a lot to that early work.
He also mentions that some details and patterns, things you might not think are important, actually matter a lot for recognition, like timing in speech.
Exactly. Things like the duration of a sound, or how much that duration varies the statistics of it. Early linguistics sometimes downplayed that, focusing just on the sequence of sounds. But Kurzweil found that incorporating these statistical parameters, the variability, was crucial for getting computers to understand speech accurately.
So the pattern includes not just what, but also how it's presented.
Precisely. And he talks about combining these hierarchical models, which learn patterns themselves, with other techniques like vector quantization or even evolutionary algorithms, genetic algorithms, to fine-tune the systems.
Which suggests the brain might also use a mix of strategies, self-organization plus maybe some built-in rules.
That seems to be the implication. The brain learns these hierarchies of patterns from experience, largely through self-organization, but may be guided by some underlying genetic predispositions. The fascinating part is the idea that the basic learning process might be relatively simple, even though it results in the incredible capacity of the neocortex.
Okay, let's switch gears slightly. What about creativity? How does this pattern recognition model explain something like having a novel idea or making a metaphor? That feels different.
Well, from the PRTM perspective, creativity, especially metaphor, is a form of pattern recognition. It's about recognizing a shared pattern or structure between two things that seem different on the surface.
So seeing a similarity in, say, how ecosystems evolve and how markets fluctuate.
Exactly. You're recognizing an underlying pattern adaptation, competition, resource allocation, despite the very different contexts. That's a metaphorical leap.
And these leaps often happen when different fields collide.
That's often where the biggest breakthroughs come from, yes. Kurzweil talks about intentionally bringing together experts from different disciplines and forcing them to create a shared language. This encourages finding those cross-disciplinary metaphors, sparking new ideas.
He uses Darwin as an example, right?
Yeah, Darwin seeing the slow, gradual changes in geology described by Lyell and recognizing a similar pattern could apply to biological evolution. That was a massively powerful metaphor that reshaped biology.
Okay, so the theory covers thinking, memory, creativity. But then the book goes into the really deep end. Consciousness, free will, identity. These are huge philosophical questions.
They are. And Kurzweil approaches them as, an engineer and scientist. He acknowledges up front that consciousness is still a profound mystery. We don't have the scientific experiments to definitively say what it is or how it arises.
Does he lean toward any particular view?
He mentions various thinkers, Searle, Dennett, Hameroff, who have very different ideas. Some see it as an emergent property of complexity. Others are more skeptical about machine consciousness. Kurzweil doesn't fully commit to one, but explores the implications from his technological perspective.
He brings up the Libet experiments, which always feel a bit unsettling.
Yeah, those experiments are really thought-provoking. They seem to show brain activity initiating an action before the person reported consciously deciding to act.
Which makes you question, when do I actually decide?
Exactly. It challenges our intuitive feeling of being fully in conscious control, raising big questions about the timing and role of conscious awareness versus subconscious processes.
And the connection to free will, if the brain acts before I decide.
Well, think about it this way. If you did something completely unconsciously, without any awareness, would you call that an act of free will?
Probably not.
Right, so there seems to be some necessary link between our experience of consciousness and our concept of free will, even if the neuroscience is complex. The feeling of making a choice seems tied to being aware of it.
And then there's identity, what makes me me, especially thinking about future tech, brain uploading, copies.
Kurzweil suggests our identity is essentially the sum total of our unique patterns, our memories, knowledge, skills, personality traits, the story of our experiences, our relationships, our projects. It's the content and continuity of our minds.
He uses that U2 thought experiment, right? A perfect copy.
Yes, if you made a perfect copy, atom for atom, you too, would be identical at the moment of creation. But from that instant onwards, every new experience, every different interaction would start to make you two a distinct identity. You'd share a past, but have diverging futures and therefore identities.
So even if I say, got a brain upgrade that enhanced my memory or processing, I'd still be me because the core patterns, the continuity, remains.
That seems to be his argument. You're modifying the substrate, perhaps, but the essential pattern that is you continues. Identity is in the pattern, not necessarily the physical stuff holding it.
Okay, going back to the acceleration idea. That difference between linear and exponential progress seems crucial to understanding his whole outlook. It's easy to miss how dramatic exponential growth is.
It really is. Our intuition is very linear. We expect things to add up steadily. But exponential growth means doubling. 10 doublings isn't 10x, it's over 1,000x. 30 doublings is over 1 billion times. That's why LOAR-based predictions often sound so extreme.
And he argues this isn't just a recent blip, like with computers.
No, he tracks exponential trends in information technology, particularly price performance, going back over a century, through multiple different underlying technologies, relays, vacuum tubes, transistors, integrated circuits.
So Moore's law is just one part of it.
Exactly. Moore's law describes the integrated circuit paradigm, but Kurzweil argues LOA is the more fundamental law driving progress across these paradigms. When one technology hits its limits, innovation finds a new way to continue the exponential trend.
Are there ultimate limits, though? Physical limits?
Oh, sure. Physics dictates ultimate limits to computation based on matter and energy, but Kurzweil calculates these limits are absolutely vast, and we're unlikely to hit them anywhere near this century. There's still enormous room for exponential growth within the known laws of physics.
But it's important that LOR applies specifically to information technology, right? Not everything goes exponentially like this.
That's a key distinction. It applies to technologies where the output of one stage can be used as a tool to create the next, more powerful stage characteristic of information processes. Not necessarily, say, the speed of cars or airplanes in the same way.
Now, obviously, these are big, bold claims. What kind of pushback or criticism does he address?
Well, one thing he calls scientists' pessimism. People working on the difficult, messy details of current problems often find it hard to buy into long-term exponential forecasts. They see the immediate roadblocks, not necessarily the bigger trend.
Understandable, I guess.
And then there are more philosophical critiques, like John Searle's famous Chinese room argument.
Right, the idea that just manipulating symbols, following rules, doesn't equal real understanding or consciousness, even if it looks like it from the outside.
Exactly. It's a major challenge to the idea of strong AI, that machines can genuinely think or be conscious like humans just through computation.
Any other major critiques mentioned?
There's also criticism from biologists like Michael Denton, who argue there's a fundamental difference between the self-organizing complexity of biological life and the design nature of machines. They question if we can truly replicate biological intelligence using engineering principles alone.
So, quite a few counter-arguments to grapple with.
Definitely. These are not settled issues by any means.
Okay, so wrapping this up. This deep dive into how to create a mind has taken us through some pretty heavy concepts. The power of accelerating returns, that hierarchical pattern recognition idea for intelligence, creativity as pattern matching, and those huge questions about consciousness and identity.
Yeah, and it's really about how these ideas, drawn from the source material you provided, connect together. They offer a framework, Kurzweil's framework anyway, for thinking about where intelligence, both ours and potentially artificial kinds, might be headed.
So maybe a final thought for you, the listener, to chew on. How could understanding the brain's way of hierarchical pattern recognition actually change how you learn something new or how you solve problems?
Yeah, and thinking about that law of accelerating returns, what might its impact be in your field, your life, your interests, even if it seems far off now?
These are the kinds of questions that emerge. Definitely worth exploring Kurzweil's book further if this sparked your interest. There's a lot more detail in there.
Absolutely. Fascinating stuff.